one, see the word exactly one, the best way to say it is one and only one. Exactly that means one and only one. Every x that's over here in the domain gets one and only one y in the range. So we got a y1, y2 over here. We don't even have to have enough, like some, let's see. We can actually have, how many? I got 7 of them over here. Let me only have 5 of them over here. It's a rule. It's some kind of rule. Okay? One way to represent it is by actually drawing an arrow that says, you go here. You go here. You go here. You go here. And then we have some ambiguity because you can go to the same, that's fine. You can go to the same, that's fine. And we can even leave this out. We don't have to use that. This guy here could go to the same as somebody else. This can be left out. You can leave things out over here, but you can't leave things out over here. Everything that's over here, because it says to each x, every x over here has to go to one y over here. And that's true. I don't have one x going to 2 different y's. Can't have that. You can't have one x going to 2 different y's. Can't have that. And at the same time, you can't leave any of the x's out. Okay, you can leave the y's out, that's fine. And you can have, more than one x going to one y, but you can't do the flip of that. You can't have x going to 2 different y's, and you can't leave an x out. This is one way to represent a function. It's not a normal way to do it, but it's called an arrow diagram. Questions about that? For each input, there's exactly one output. That's a good way to say it. That's what it says. For each input, there's exactly one output. All right, good. So that's one way to represent a function. It's called an arrow diagram. Another way to represent a function is with a formula. Okay, the notation that we use, we read this as y of x. Y of x is equal to some formula for x on the right-hand side. Square root of 3x minus 5 plus 7 over x squared. Some formula on the right-hand side. That's a way to represent a function. We can use the arrow diagram. We can use a formula. We can use a machine to go along with this formula. We're going to put some inputs in, do something to them, and some output is going to come out. So x is going to go in, y is going to come out, and this is the thing that you do to them. Root 3x minus 5 plus 7 over x squared. So this is a function machine, but it's the same thing as the formula. It's a different way of looking at it. Another way to represent a function. We can represent a function in set notation. where we have a set of ordered pairs. Okay, set notation is curly braces. And then the outputs and inputs, they're separated, just like we do in an ordered pair. The input comes first and the output comes second. So 1 goes to 4, and 3 goes to 8. And 7 goes to -4. 5 goes to 1. And that would be a function where these guys are my inputs. There's only 4 of them. And I have to make sure that they go to one and only one output, and they do. If I had a repeated input, then I better have the same output. I can't have something like this, where I take another point in here and say 3 and make it go someplace else. -9, I can't put that in there. This can't be in there with the rest of them. I can't have that. 3 going to -9 and 3 going to 8. Three is going to 2 different outputs. That's not a function. So I can use set notation to describe my function. I can use a formula to describe my function. I can use a graph to describe my function. Okay, some function f of x. Now the way you tell whether you have a function by looking at the graph, what you have to do is you have to use what's called the vertical line test. Every vertical line, that's isolating the x, every vertical line can only touch your graph once and only once. That means it's only going to one y. Every vertical line can only touch your graph once. Intersect or touch the graph. Okay, then it's a function. And so, every vertical line only touches the function once. So what does it look like when that fails? It might be going well at first, but maybe the function doubles back or something like that. Or circle. That doesn't work. There are some vertical lines. I guess the y-axis itself is a vertical line that has 3 different places where it crosses the axis. I mean, crosses the graph. Here's one, though, other than that. 1, 2, 3 places where it crosses at. Every line here is going to cross twice, except for the one that happened at the ends there. These guys aren't functions.